Hello everyone, so in this video we're going to discuss about apply maximum and minimum problem. Let's say we took a function, y is a function in terms of x. Then we learned that there was a process called differentiation to find the derivative. The derivative, we can write it as dy dx or as function y prime in terms of x, or write it as y prime. So what we have done there is found the rate of change of a function. That's a rate of change is just simply given by the gradient. So the gradient is just measuring how quickly something is changing. So the rate of change of a function is the same as saying the gradient of function. Let's say if we have the curve of function, if we had a curve, we can find the rate of change by looking at the tangent right here. So the gradient is, in other words, for the tangent. With a function like x squared plus 6x plus 3 and then differentiate it, we will get to x plus 6. Let's try to sketch the function and let's say that we put the gradient there. If we see, we have the different gradients depending on which one you look at, because with an x squared graph, you draw a tangent in. The gradient of a tangent depends which point you look at. The best we can do is come up with a function that will give us the gradient of a function. So the gradient of a tangent is another function because we basically just plug in a point in. Let's say that this is x equal to 2. We plug the point x equal to 2 into this function right here, and it will give us the gradient of a tangent at that point. We can see here when we plug in 2, the gradient is 10. So you can see depending on which point we put in, we can carry on and you can put in any single point. But the point is, we got a function that will tell us what our gradient is, or whatever point you put it in, because the gradient is going to be different at different points. When do we apply differentiation? The field of the use of differentiation are very wide. It enters into many fields and are not limited to specific people or to those who use it only, but to all human beings.
Now let's see other application for differentiation. What if we need to find the size of the water that will fit in the swimming pool? It will be easier to students to find the size of swimming pool if the shape of the swimming pool is in cubic or rectangle. It will be hard for students to find the size of the swimming pool if the shape of swimming pool have gradient. But by using the differentiation, it will be easier to students to find the size. Next, let's see video game. Video game always be played by people right now, and what we didn't know is all the statistics that players see during the race on the screen include the speed of the car and the distance each participant in the race are actually calculation of differentiation and integration are done in the moment. For our problem statement, an offshore oil well being is in W in the middle of the ocean 5 km from the nearest point A on the beach. Crude oil will be delivered to be located 8 km from A via a straight pipe at the sea base from W to P point located between A and B, and then to B via pipeline along the coast. If the cost of the installation pipe at the sea and on the coast is Rm 100,000 per kilometer and Rm 75,000 per kilometer, where the point P must be for the cost of the installation of the minimum pipe. Let's see our objective. First, we need to determine the value of x, which is the distance of point P from point A, and second, we need to determine the minimum cost for the installation pipe. To understand more about the problem statement, here is the diagram for the statement. We can see here, this is W, P, and B where the crude oil will delivered. And we also can see WAP is actually triangle, and we can use theorem Pythagoras to get the value of x at here. And we also can know that cost for installation pipe at the sea is Rm 100,000 per kilometer, while at the beach is Rm 75,000 per kilometer. And our main problem for this problem statement is where we need to put the point P to get the minimum cost for installation pipe.
Let's go with the step 1. Step 1, we have to find the distance and the cost for WP and PB. If you look at the diagram, the distance for PB is 8 minus x. To find the cost, we have to multiply the distance with the cost. So it becomes 75,000 times with 8 minus x. For WP, the distance is 5 square root 5 squared plus x squared. This is because if we look at the diagram, WAP is triangle, so we can use the theorem of Pythagoras to get the distance. To find the cost WP, we just need to times the cost with the distance. So the total cost is the cost PB plus cost WP. So we got 75,000 times 8 minus x plus 100,000 times square root 5 squared plus x squared. We go to step 2. For step 2, we need to get the total cost for WB through point P. If we see the diagram just now, in order to get the total cost for WB through point P, we need to plus the cost for WP with the cost PB. But first, we need to differentiate it. Differentiate the cost WP plus cost PB. So C prime x equal to D over dx 75,000 times 8 minus x plus D over dx 100,000 times square root 5 squared plus x squared. And then we bring the 75,000 and also 100,000 to the front, so we just differentiate the 8 minus x and also the square root 5 squared plus x squared. After we differentiate it, we get the 8 minus x, we get negative 1. But for the square root, we have to change the square root to the power of 1 over 2 to make it easy to differentiate. We bring the power to the front, and then we differentiate the 5 squared plus x squared. We got 2x because the power goes down. And then the 25 plus x, so we just need to follow that. And then how we get negative 1 over 2 is because we need to minus with 1s. 1 over 2 minus with 1. And that's how we get negative 1 over 2. After that, we bring down the 25 plus x squared. So it becomes 2 times 25 plus x squared 1 over 2, because we bring down the negative 1 over 2, so it becomes positive, right, for now. And then we get this answer right here. After that, for the critical point, we have to equal with 0. So 0 equal to negative 75,000 plus 100,000 x over 25 plus x squared power of 1 over 2. So the 75 here, negative 75, bring down to the front, got negative 75,000, and then also this thing will bring to the left, and then we get 75,000 square root 25 plus x squared, because we change this power just now to square root. To get rid of the square root here, we need to square root both sides. So after we have square root the both sides, the square root gone, so we get 25,000 squared times 25 plus x squared equal to 1 times 10 power of 10 x squared.
For the step 3 is second derivative test. This step is compulsory, so we need to do this step. After we get a C prime like this at the previous step, we need to differentiate the C prime again for the second time. And here, after we differentiate negative 75,000, it will be 0 because negative 75,000 is a constant. and here we will see this is rational function, so we need to use equation rule. For the numerator we will set as u, and for denominator we will set as v. So for u, when we differentiate 100,000 x, it will be 100,000, and for v we will get 25 plus x square power of 1 over 2, and we also can rewrite as root of 2 for 25 plus x square, because power of 1 over 2 is actually root of 2, and when we differentiate it we get 1 over 2 multiplied with 2x multiplied with 25 plus x square minus power of negative 1 over 2, and we can rewrite like this because power negative 1 over 2 will be positive when it at the denominator, and here 2 we can cancel out, so it will be the final answer for v prime. Next we need to substitute the value of the u prime, v and v prime in this equation, and here we get this, and after that I change this bracket to the root because it will be more easier for me, and next I multiply with the root of 2 for 25 plus x square because I can cancel out this and it will be more easier for me to solve this equation. And here we get, so how that I get 1 over 25 plus x square is because I bring out this part and it will be 1 over 25 plus x square, and before that I cancel out this power of 2 with the root of 2, and after that it will be like this, and this we can see this is power of 1 because this square root is actually 1 over 2, and we can actually plus with 1 over 2 also, at this square root, because square root multiplied with square root is actually plus, so here we get 1, and it same goes to here, this 1 over 2 and this is 1, so 1 over 2 plus 1 it will be 3 over 2, and after that I expand this part. After I expand from the previous step I will get this, and here we will see positive 100,000 x square minus 100,000 x square, and it will be 0, so we can write like this, and after that we just substitute the value of x that we get from the step 2. So the value of x is 5.67, so after we substitute the value of x we will calculate with calculator and we will get this, and here we will see 5786.663 is actually a value test, so we can use this value, and we also can see this value is actually more than 0, so that means the value of 5.67 is the mean value. For our last step is we need to determine the minimum cost for installation pipe. Here we will get an equation of cost of the pipe, and we need to substitute the value of x that we get in step 2 is 5.67, so after that we just calculate it with calculator, and here we get the answer, and the total of minimum cost for installation pipe is Rm 913,780 ringgit and 91 cents.
From the conclusion, we can conclude that the distant point P from point A, which is x, is 5.67. And after we solve the problem, we know that the minimum cost for installation pipe is 903,718 ringgit and 91 cents. This is the list of the reference that we have used in making this video. Thank you for watching this video.